Our topic for today is about Laplace transform. So, first, what's the importance of learning Laplace transform? Now, we have encountered different ways of solving differential equations. Now, a Laplace transform is one of the methods of solving differential equations, and it was believed to be an easier way, but we have to first go to the basics of getting Laplace transforms before we will proceed to using Laplace transforms in solving differential equations. Now, Laplace transform for a Laplace transform, let's start first with finding Laplace transforms of functions of, let's say, functions of t, okay, or that is f of t. Okay, so a Laplace transform of a function of t is represented by f of s. Okay, and that is also represented by cursive L, which denotes the Laplace transform, cursive L of f. Okay, so when we are going to find Laplace transform of a function f of t, that is being symbolized by capital F of s or cursive L of f. Okay, so let's have a formula for getting a Laplace transform. So for a given function f of t, its Laplace transform is equal to the integral of e raised to negative s times t, then times f of t dt from the limits 0 to infinity. So this is the formula of a Laplace transform of a simple function f of t. Okay, so now let's have an example. Let's say f of t, given function f of t is equal to 1. Okay, now let us get the Laplace transform of a function of t equal to 1. So that's capital F of s or cursive L of 1. Okay, so that is integral of 0 to infinity of e raised to negative st times 1 dt. Okay, so in this case, we will be using the formula integral of e raised to u times du, which is negative s dt. And in this case, to retain the original integral, we'll have negative 1 over s outside of the integral sign constant, and still from the limits 0 to infinity. So this is now equal to negative 1 over s times e raised to u, which is negative st from the limits 0 to infinity. Then we have negative 1 over s. Okay, we will substitute t first with infinity, then minus with 0. So we have e raised to negative s times infinity, then minus e raised to negative s times 0. Now, any value raised to 0 will always be equal to 1. Okay? And any value raised to infinity will always be infinity. So in this case, if we have e raised to negative s times infinity, that's the same as e raised to negative infinity. Okay, and that will be the same as 1 over e raised to infinity. And any value raised to positive infinity will always be equal to infinity. So we now have 1 over infinity, and any number divided by infinity is always equal to 0. So the value of e raised to negative infinity is equal to 0. So this is now equal to negative 1 over s times 0 minus 1, or that is positive 1 over s. Okay, so therefore, Laplace transform of function of t equal to 1 is 1 over s. Okay, next. How about, let's have given f of t is equal to t. Okay, let's get the Laplace transform of function of t equal to t. So that will be integral of e raised to negative s times t times f of t, which is equal to t times dt from the limits 0 to negative infinity. Okay. Okay. So here we have to use integration by parts. Okay. So for the integration by parts, our u will be t, and our du will of course become dt. And then our v will be e raised to negative st dt. Okay, so integrating both sides, rather dv. Okay, so v will now be equal to negative 1 over s times e raised to negative st. Okay, so this is now equal to, you have uv, so you have u times v, or that is negative t over s times e raised to s negative st, so that is u times v, okay, minus integral of v negative 1 over s e raised to negative st times du, which is dt. Okay, now all of this will be from the limits 0 to infinity. So simplifying further, we'll have negative t e raised to negative st all over s, then plus 1 over s integral of e raised to negative s dt. Okay, so we now have negative t e raised to negative st. Okay, then 1 over s, then derivative of negative st dt is equal to negative e raised to negative st all over s. Okay, so everything from the limits 0 to infinity. Okay, so let's just simplify this one. So we have negative t e raised to negative st all over s minus e raised to negative st over s squared. So you have 0 to infinity. Okay, now if we are going to substitute everything with infinity, okay, what will happen, okay, is that t will be substituted with infinity. So that will become e raised to negative infinity, and that will lead to a value of 0. So therefore, for substituting upper limit, everything will be equal to 0. Then we have minus, then we will now substitute everything or the value of t with 0. Okay, so substituting value of 0 in this first term, we have t 0, so everything would become 0 here. And then minus, we have e raised to 0, or that is equal to 1. So you have 1 over s squared. Okay, so this is now equal to 1 over s squared. So therefore, the Laplace transform of the function of t equal to t is 1 over s squared. Okay? Now, for given function of t, ito pa lang, simple pa nga lang ang function pero ang haba na ng solution if we are going to use this formula. Now, I will provide you with a list of common functions of t and their Laplace transforms. Okay. So, yan. Okay. So, again, yun. For given f of t, okay, what will be its Laplace transform? Okay, so kanina, we already solved. If f of t is equal to 1, the Laplace transform is 1 over s. Now, if f of t is equal to t, the Laplace transform is, sana yun? 1 over s squared. 1 over s squared. Now, if the function of x, a function of t is t raised to exponent n, okay, now, that will be equal to, a transform of this function of t is, we have n factorial all over s raised to n plus 1. Okay? And then the Laplace transform of e raised to a times t is equal to 1 over s minus a. Okay? Now for ano pa? Okay. Laplace transform of sine of at is a all over s squared plus a squared. Ano pa ba? What else we have? Cosine of at, the Laplace transform of that function is s over s squared plus a squared. Okay? Meron pa. So, for a function of t, you have its corresponding Laplace transform. Okay, so this is our first formula. Second, third, fourth, fifth, and then we have sixth. Okay. So, seventh formula, we'll have cosine, hyperbolic cosine of at. Okay. That will be, sana ba yun? S over s squared minus a squared. Now, if the function is hyperbolic sine of at, okay, the transform of that is a over s squared minus a squared. Now, next, if we have sine of at squared, the transform of that is 2a squared all over s times s squared plus 4a squared. Number 10, okay, cosine 80 squared, that's s squared plus 2a squared all over s times s squared plus 4a squared. So, these are the common formulas of Laplace transforms for given function of t. Now, let's have another example of Laplace. So, if we have two functions of t, okay, let's say if you have function function f of t plus function g of t, the Laplace of f of t plus g of t, Laplace transform is just equal to Laplace transform of f of t plus the Laplace transform of g of t. So we could apply this one. Okay? So for example, we have, okay, find the Laplace transforms of the following. Okay, say t raised to 3. So we know that the Laplace transform of t raised to n is equal to n factorial over s raised to n plus 1. So this one. Okay, as I have mentioned earlier. Okay, we will just use this formula instead of using the long formula where the Laplace transform of a function is equal to integral of e raised to negative st times f of t function dt from the limits 0 to infinity. So if we will use this to get the Laplace transform of t cube, then it will really take us, it will really take time, no? Ito pa nga lang, function ng t is 1, medyo mahaba na and medyo confusing. And also this one, medyo mahaba na, may integration by parts pa, no? We'll just use the common formulas, one of the common formulas of Laplace transform. So we will use formula wherein the Laplace transform of t raised to n is equal to n factorial all over s raised to n plus 1. So in this case, n exponent is equal to 3. So the Laplace transform of t cube therefore is equal to 3 factorial all over s raised to 3 plus 1. 3 factorial is equal to 3 times 2 times 1 all over s raised to 4. So you have 3 times 2 times 1, that is 6 over s raised to 4. So the Laplace transform of t cube is 6 all over s raised to 4. Okay, another example. We'll have number 2. Okay, so let's say the function given is t raised to 4 minus 5. So the Laplace transform of the given function or the f of s, that is equal to, okay, Laplace transform of t raised to 4 minus Laplace transform of constant 5. Now, for a constant, okay, you could pull out that constant. You have minus 5 times the Laplace transform of 1. Okay? So, ang Laplace transform ng constant is the constant itself times Laplace transform of the function of t. So, in this case, that's equal to 1. So, this is now equal to, okay, using this formula, you have 4 factorial over s, 4 plus 1, minus 5 times Laplace transform of 1. Laplace transform of 1 is 1 over s. So, you have 5 times 1 over s. Okay, and this is equal to, okay, 4 factorial is 4 times 3 times 2. So, that will be 24. Okay. All over s raised to 5 minus 5 over s. So, this is now the Laplace transform of t raised to 4 minus 5. Okay. Number 3, we'll have t squared minus t everything raised to 2. So, for us to easily get, since this function has an exponent 2, it will be difficult for us to directly get the Laplace of this one, dealing with this exact, this direct function. So let's just expand. So this will be t raised to 4 minus 2t cubed plus t squared. Okay, so we'll now get the function of t raised to 4 minus 2t cubed plus t squared. So Laplace transform of the given function, we have Laplace of t raised to 4 minus 2 times Laplace of t raised to 3 plus Laplace of t squared. Okay, and that will be t raised to 4. So kanina we already have it. That's 24 over s raised to 5 minus 2. Laplace of t cubed, we already got it. That's 6 over s raised to 4. 6 over s raised to 4. And Laplace of t squared is 2 over t squared. That's 2 factorial or 2 over s, 2 plus 1, 3. Okay, so to simplify, you have 24 over s raised to 5 minus 12 over s raised to 4 plus 2 over s cubed. Okay, you could actually factor that out. This is already acceptable, but you could factor out the common factor. That will be 2 over s cubed. Then, times, you have 12 over s squared minus 6 over s plus 1. Okay, so pwede din ito, final answer. Okay. Yan. Okay. Next example. What if the given function is cosine of 3t? Now, we will use the formula Laplace of cosine, sana yun? Laplace of cosine at is s over s squared plus a squared. Okay? So, again, Laplace of cosine at is s over s squared plus a squared. So, in this case, ang a mo dito is 3. Okay? So, the Laplace of the given function is, we have s over s squared plus 3 squared. Or that is s over s squared plus 9. Yan. That's how easy it is. Okay? Next example. Example number 6. What if the given function is sine of 4t? Now, we will use the Laplace transform formula where Laplace of sine at is equal to a over s squared plus a squared. Okay. That one. Okay. So, in this case, the a here is 4. So, that will be Laplace of the given function is 4 over s squared plus 4 squared, or that is simply 4 over s squared plus 16. No? As you can see, Laplace transforms are expressed in terms of functions of s. That's why ganito din siya. Aside from this denotation. Okay. So, that's it. Those are the examples of getting Laplace transforms.